So, let's say that you're still confused about naming formulas. Let's try this. Since we're naming formulas, remember that there are 4 kinds of compounds that we'll be naming. So the first thing that you should do is narrow down which compounds you might be using. So let's say that first you look at the compound and you notice that the very first element happens to be metallic. If that's the case, then you know that you are working with something that is in fact ionic. You have 2 choices for ionic compounds. The first one are those that we would consider simple. Those were the first ones that we did in class. The reason that they're simple is that there's nothing really fancy about them. The metal ion only has one possible charge. And you can see that by looking at the periodic table. Once you know that that's the possible charge, naming it means that you're literally going to write the element's name. The other way of doing it would be if instead you look at that ionic compound and you notice that it's a little bit more complicated. That's because the metal happens to have more than one charge. So maybe it's +2 or +4. And again, you see that there are multiple possibilities because you're looking at the periodic table. At this point, you need to figure out what the charge is actually going to be. In order to do that, you want to also identify what the anion is. That means that if you happen to realize that the anion is a single element, it's going to be a single nonmetal. And if that's the case, it happens to end in IDE. Since it ends in IDE, you can look on your periodic table, and those ions that are listed, you're going to see that there are 2 variations, right? Or rather 4. You're going to have those that are halogens as -1. You're going to have those that are the oxygens. Those are all -2. Under the nitrogen family is -3. And under the carbon family is -4. So if your ion ends with IDE, you happen to have one of those. On the other hand, it might be polyatomic. And if it's polyatomic, chances are the ion ends in ATE or it ends in ITE. Those both mean that you need to not look at the periodic table, but rather you're going to look at the yellow sheet. And the yellow sheet will end up telling you what actually is involved and what the formula looks like, as well as the charge. Now I'm pointing that out because, again, what we want to do is if you realize that you happen to have a multiple charge metallic ion, you have to figure out what the ion is going to look like. So once you have your polyatomic ion or your single nonmetal anion, you can go ahead and figure out the charge of your metal. Once you know the charge of your metal, you're going to go ahead and give it its element name, followed by some sort of Roman numeral in parentheses. That Roman numeral is in fact going to represent the charge of the metal. Okay, so let's say that your first element was not metallic. At least you know then that it must have been covalent. There are 2 kinds of covalent compounds. The first kind of covalent compound are those which happen to be acids. You're going to recognize an acid because it's going to start out with the letter H, and then there's some sort of anion. The anion is the thing that dictates what to do next. If that anion is a single nonmetal, then you're going to go ahead and name that acid starting out with hydro, followed by the nonmetal's root, then ic, then the word acid as a separate word. That's how you name what we call binary acids. Not all acids are binary. Most acids are in fact polyatomic anions. So if you remove the H and everything after that H happens to be polyatomic, then you're going to go ahead and look at the yellow sheet. When you find that yellow sheet, you're going to see that there are two versions. Either the anion ends with 8, or it ends with ite. If it ends with 8, change that ending to ic. But if it ends with ite, change the ending to ous. Some of them you're going to have to be careful of, like sulfur. You'll need to add the ur, so that sulfate becomes sulfuric. Or phosphite, you'll need to add an or. Phosphorus, as phosphite, will be phosphorus. So you want to watch out for those. Again, follow those endings with the word acid. Your other covalent compounds that we'll be working with are those that are binary. So at this point, you've ruled out that it was metallic. You've ruled out that that metal had multiple possibilities. You've ruled out that the formula was in fact an acid, and now all you're left with is binary, where there are now two nonmetals. At this point, and only this point, are you now allowed to name the nonmetals according to their regular names, as well as with a prefix. For the first nonmetal, you can only use a prefix if it's greater than 1. For the second nonmetal, you have to always use a prefix. Not only is that true, but you're also going to end that second nonmetal with an IDE ending. So two things are going to end up happening. One, you're going to name the first nonmetal, again, only with a prefix if it's greater than one of those nonmetals. And then second, you're going to go ahead and name the second nonmetal with a prefix and change the ending to IDE. All right, at this point, we're going to do a little bit of practice. So I've shrunk our little flow chart here, and we're going to go ahead and look at some formulas. So let's say that we start out with something that looks like H3BO3. The first thing you notice is that the first element isn't metallic. It's not. We're starting out with a hydrogen. Since that's the case, we're going to go ahead with something that is covalent. Since it's covalent, we're now going to ask ourselves, is that in fact an acid? And it is an acid because, again, it starts out with the hydrogen. You're then going to indicate what is occurring with the BO3. So all of the H's get dropped, and just focus on that BO3. It is a polyatomic anion, so now we're going to find it on our yellow sheet. Once you've found that BO3, you're going to notice that it's called borate. The BO3 ion as borate means that we're going to drop the ATE ending, and as we drop that ATE ending, we'll replace it with ic. We're also going to replace it with the word acid at the end. So now our formula H3BO3 is called boric acid. Let's try another one. Let's say that you happen to be doing Hg2SO4. Again, the first question that you want to ask yourself is this in fact metallic for the first element? So is mercury metallic? It's on the left side of the periodic table, so yes it is. That's ionic. Now that we know that it's ionic, we're going to look at the periodic table. Those tiny little oxidation numbers are right above the symbol. If that oxidation number is only one possibility, you know that you're going to end with a simple ionic compound. On the other hand, if that metal has more than one possibility, you know that you need to figure out the charge of it. In our case, we do have more than one possibility. Hg could be +1, but it could also be +2. Therefore, we're going to look at the SO4 ion. The SO4 ion is -2. If SO4 is -2, then 2 mercuries have to join up with the SO4, which is -2, and add together to come out with an overall net charge of 0. That means that each mercury is in fact +1. Having noticed that now, we're going to go ahead and we're going to again name the element, which is mercury, and we're going to follow it with a Roman numeral. In this case, that Roman numeral is 1 because the mercury ion is +1. We're then going to follow it with the sulfate ion because that was the polyatomic ion that it was joined to. Let's try another one. Let's say now that you're told you have Li3N. Again, is the first element metallic? Yes, lithium happens to be metallic. That's how we're going to know that we're working with an ionic compound. We're now going to look on the periodic table, and on the periodic table, lithium is in the first family. That means that only one possibility exists. That possibility happens to be Li+1. We're now going to notice the anion, and in our case, the anion is a single element, that's nitrogen. Since it's a single element, the nitrogen needs to be one of these families. Since nitrogen is listed in the -3 family, we know that we can call it nitride. So now we're going to name the first element, that's lithium, and the second element, nitride. And so the name of this compound is lithium nitride. Let's try one more. So you're told that you're working with N2O5. Again, is nitrogen, the first element, metallic? Since nitrogen is on the right side of the periodic table, the answer to that is no. That's how you know you're working with a covalent compound. We do not have an acid because nitrogen is not hydrogen. We do, however, have 2 nonmetals, so we're going to go with binary. Since the name of the first element is nitrogen, we just need to decide whether there is more than one nitrogen present. There is because of the 2. Looking at the prefixes, that means we'll call it dinitrogen. We'll then name the second element, oxygen, with an IDE ending, and we also want to make sure that we represent how many oxygens there are. Now normally we would call it pentoxide, but if you happen to name it pentaoxide, that's okay. So this compound is dinitrogen pentaoxide.